Hello everyone, my name is Burak. I am from the Department of Electrical and Electronics Engineering from Bilkent University. Now I'm going to present you my Physics 101 project, which is about double Atwood meshing by using the concept of Lagrangian explanations. So in this experiment we have two pulleys, as you can see over here. One of them is attached here, and the second one is attached here. So in this experiment, I have attached a 20-gram mass here in the position of mass 3, and over here in the position of mass 1, I also have a 20-gram mass, and those are metal weights, which you can see here. And for this purpose, to calculate, to measure their mass, I used an electronic balance, as you can see over here. So in this experiment, I just changed the mass of mass 2 position, which is this one over here. I attach different masses by measuring the mass in the electronic balance, and then I just put it at such a position that it will just remain at the 0.0 centimeter point of my ruler, which is attached perpendicular to the ground and also perpendicular to my masses and the system. And also I took video footage from a perpendicular position of the camera, and I used a stopwatch to calculate the time taken for this mass to move that far. And while doing this, I put the stopwatch like this and arranged the mass at such a position that it was at 0 point. Then I start the time. As you can see, it is 0.50 seconds. And then I check how far it moves. As you can see, it is 88 centimeters. Therefore, we know that acceleration is equal to 1/2 at squared, where a is equal to acceleration and t is the time interval. So I will just insert 0.50 seconds into the equation and calculate the actual acceleration. Then I will just take my masses and calculate their mass, measure their mass. As you can see, it is 60.66 grams. So, after using this equation, I found the following results, as you can see in the video right now. Then I replaced the amount of masses attached to the position of M2 by calculating the new amount of mass on an electronic balance, and for each condition I have collected 3 trials to increase the reliability of my results. And I had 5 conditions in total. After processing the data collected from the experiment, I found out that the experimental findings were pretty close to the theoretical ones. But there were some problems in this experiment as well. So I used a wax in this rope in order to prevent it from slipping off the pulley. But still, there is the factor of friction in this experiment. Therefore, there were some little fluctuations away from the Lagrangian equation explanations. However, still, I increased the reliability of the results by using a video footage to see whether if I was really measuring 50 seconds. Because due to the human error, I have to restart and stop the stopwatch. Therefore, by using a video footage, I calculated the exact time taken. The graphs on the screen present how there was a relationship between the mass of M2 in grams from diagram 1 versus its acceleration in meters per second square. Still, while sketching this graph, the first data that was obtained was neglected due to having an anomalous results compared to the other trending 4 data. Perhaps an external force was applied in the vertical axis which caused this anomalous effect, since this was the very first trial of the experiment. Consequently, by using the Lagrangian mechanics as a background to this project and using the experimental setup that was conducted, it can be seen that the rate of change of acceleration of M2 from diagram 1 decreases as the mass of M2 increases. Yet overall, As the mass of M2 increases, the acceleration of M2 increases in double Atwood's machine.